How can transfer learning speed up CNN image classification? Imagine trying to teach a child to recognize thousands of different objects. It would take forever, right? Now think about how computers learn to do the same task. Transfer learning makes this process much faster. In the world of convolutional neural networks, or CNNs, training from scratch can take days or even weeks. This is because CNNs need to learn millions of parameters to recognize patterns in images. But what if you could start with a model that already knows how to spot basic features like edges, textures, or shapes? That's what transfer learning does. It uses models that have already learned these features from large datasets, like ImageNet, which has over 1 million labeled images. Instead of training a CNN from zero, transfer learning begins with a pre-trained model. These models, such as VGG16 or RaiseNet, have already captured useful visual features. You then fine-tune only the later layers of the model to adapt it to your specific task. This means you only need a smaller dataset and less training time. For example, if you want to classify medical images, you can start with a pre-trained model and just adjust it for your specific images. This process can cut training time from days to just a few hours. The reason this works well is because CNNs learn hierarchical features. The early layers detect simple patterns like edges and textures, which are common across many types of images. The deeper layers recognize more complex structures. By reusing the early layers, transfer learning allows the model to quickly adapt to new tasks without relearning basic features. This approach is especially helpful when labeled data is hard to get or expensive. For instance, in medical imaging, collecting thousands of labeled samples can be tough. Transfer learning allows models to perform well with fewer examples, saving both time and resources. It is also used in industrial applications, like recognizing defects in manufacturing, where training data is limited. Using pre-trained models not only speeds up training but can also improve accuracy. Because the model starts with a strong foundation of visual features, it often outperforms models trained from scratch. Plus, it reduces the computational power needed, making AI more accessible and environmentally friendly. In summary, transfer learning accelerates CNN image classification by reusing learned features from large datasets. It reduces the need for extensive labeled data and long training times, helping developers create effective models faster. This method is a key part of modern AI, making powerful image recognition tools more practical and sustainable.